There are several factors involved in muscle contractions. One of the factors involved with a muscle contraction is the type of contraction. So here's a great example of two different types of muscle contractions. One is called an isotonic contraction. That means the muscle tension is greater than the load. So if you look at my little diagram here, the muscle tension is the guy's curling some weight. If it's greater than the load, the joint is going to shorten its angle and the muscle is going to contract. So a concentric contraction means you're shortening that angle, and eccentric one means you're increasing that angle. Flexing compared to extending, contracting compared to extending. An isometric contraction is where the muscle tension is less than the load. So in that case, you're not contracting the muscle, you're holding the muscle. So the muscle is flexing, but it's not shortening. So we use isometric contractions, for example, to maintain posture. So this would be a case where you're just holding on to something. Summation is what enables us to do just that. Here are some of the major factors related to muscle contraction. Think of the acronym SLRM. Now, I know that doesn't spell anything, and if you can make it spell something, that'd be great. But SLRM, summation, length, tension, energy, recruitment, muscle type, all factors that go into muscle contraction. So let's start with this idea of a motor unit. Motor unit are the cells and the nerve that controls them. So if you think of it like a military analogy, the nerve is like the commanding officer, the cells are like soldiers. So sometimes we need different motor units for different jobs. All right, so a motor unit's the nerve and the muscles that it controls. So every time your muscle contracts, the whole muscle contracts. But how can you contract that muscle with different amounts of force? Like if I pick up a pencil compared to a 50-pound weight, how do I do that? How do my muscles know how much strength to exert? Recruitment is the answer. So just like in the military, if you want a large military, you have to recruit individuals. If your muscle has a big job, it's going to have to recruit a lot of motor units. Those are the nerves and the muscle fibers that are necessary. So motor units come in all different shapes and sizes. So here's an individual just lifting a small amount of weight, so they're using a motor unit. Well, if they want to lift more weight, they're going to have to engage additional motor units. So now that they're lifting a heavier weight, they're engaging more motor units. Well, if they want to lift a lot of weight, they might have to engage all their motor units. So in this case, they're trying hard, but can't lift the weights. Even though they've activated all their motor units, they don't generate enough strength to lift that weight. So we have a variety of motor units for a variety of jobs. If you look at the first diagram, that motor unit is useful to lift that smaller weight. And what will happen is your whole muscle will cycle through different motor units as you do reps with that weight, so that not just one motor unit is getting tired out. If you look at the second picture with the greater amount of weight, that person's body has a couple options for lifting that large weight. It could use a large motor unit that consists of very large muscle fibers. Or like B, it could engage several motor units that all have a few fibers. Or like C, it could engage a motor unit that has a lot of fibers. All of them could do the same amount of work, and that muscle is going to cycle through using those different motor units as the person exercises with that weight. Length tension relationships, so SLRM, this is the L. That refers to the sarcomere length and the tension placed on it. Remember, sarcomeres are where actin and myosin kind of overlap. So if the overlap is too great and your muscles are too tight, it's not going to be ideal for muscle contraction. You're not going to generate a lot of force. If the muscles are too stretched and there's not a lot of overlap, there's not going to be enough overlap to create a lot of force. So we warm up to loosen up tight muscles, to tighten up stretched muscles, and try to create that optimal range where we can have a strong muscular contraction. Summation is the idea of adding together individual twitches or summing individual twitches. We can increase the strength of a contraction if we can make that muscle contract before it has a chance to relax completely. That allows us to grip and hold things, summation. When your muscles are completely contracted, that's called tetanus. When they're unable to stay contracted, that's called fatigue. There's a difference between something called wave summation and temporal summation. Wave summation adds those twitches to one another. A temporal summation is where you have two twitches that arrive kind of close in time, and so they add together. Complete tetanus means that your muscle is completely contracted, there's no fluctuation, there's no relaxing at all. But incomplete tetanus means that we have a change in the length of the muscle is contracting, but we're not completely contracting every single motor unit available. When we talk about muscle tone, we mean that our muscles stay slightly contracted. The threshold is the minimum stimulus that we need to get that muscle to contract. So sometimes we might think about contracting our muscles, but we don't. A twitch is where the muscle fiber is completely contracted and then relaxes. So we need a stimulus, some nerve signal that causes the muscle to go from contracted to relaxed. That stimulus is going to help those cross bridges detach so that the muscle can now relax. To do that, we have to remove the calcium so that the tropomyosin returns and creates the safety around those actin and myosin fibers. That's it for this video. I'll see you again next time.